Page 578, continuing lesson 9.5 on completing the square. Right above problem 4, it mentions the method of completing the square works when a equals 1 and ax squared plus bx plus c equals 0. To solve an equation when a is not equal to 1, divide each side by a before completing the square. So think back to what we looked at in the previous part of this section. Everything was just x squared something. There was no number in front of the x squared. And that's how it has to be when we do these completing the square problems. So if there's a number in front of the x squared, you've got to divide each term by that number before you get going. So if you look at problem 4, you are planting a flower garden consisting of 3 square plots surrounded by a 1-foot border. The total area of the garden and the border is 100 square feet. What is the side length x of each square plot? So if you look at this, they've got a nice picture drawn for us. And then if you think about the overall dimensions, over here, this dimension overall would be x plus 2. And then going across, if you look at all the pieces we have, that would be equivalent to 3x plus 2. So it tells us the area, total area of the garden and border is 100 square feet. So what they're doing then, area of a rectangle is length times width. So length times width equals 100. And then they went ahead and just FOILed this out. They combined their middle terms and they got 3x squared plus 8x plus 4 equals 100. And then they went ahead and subtracted 4 on both sides. It's kind of like they're assuming that this is not going to factor. So they're like vacating the constant over to the other side like we did in the first part of this section. And then after they did that, there's a number in front of the x squared. So then they had to divide each of the terms by 3. And that's how they got this. X squared plus 8/3 x equals 32. Again, I like to have a plus blank on both sides, so I've got a spot for my constant. So like we did yesterday, we're going to take half of that b term and we're going to square it. So half of 8/3 would be 4/3. And then if you square 4/3, that's like 4/3 times 4/3, which is 16/9. That's how they got the 16/9 down here. And again, if we add it on one side, we've got to add it on the other side to keep our equation balanced. At that point, over on the right side, we want to combine those together. In order to do that, we need to get a common denominator, which would be 9. So common denominator of 9, combine those together, ends up being 304/9. This is looking really nice. Maybe not. And then now we're ready to take the square root on both sides, plus or minus. When you do that, they went ahead and just got an approximation for what that is. Sometimes we might be asked to find the exact and approximate answers, so I'm going to go that route, a little different route than what the book took at the end here. So we can split that square root up, since the square root's over that whole fraction. And when you do that, square root of 9 is 3. Then they're adding 4/3. We need to subtract 4/3 on both sides. I'm going to squeeze that in front of this other fraction. And then generally what's going to happen here is that our denominators will be the same, and so we can actually combine this together as one big fraction. So negative 4 plus or minus square root of 304 all over 3 would be our exact answers. That's two answers, plus square root of 304 and minus square root of 304. And then if you work out the two different options there, you should get what the book has, which is about negative 7 and 1/4. I'm sorry, negative 7 and 14 hundredths, or 4 and 48 hundredths. Now we know this is X is talking about the width of the border. The width of the border can't be negative 7 something. That doesn't even make sense. So the 4 and 48 hundredths would have to be our X. Oh, sorry, it's actually not the width of the border. It's the dimensions of each section of our garden. So each section of the garden is about almost 4.5 feet by 4.5 feet. And then we've got this border going around the whole thing. On the Got It 4, they're taking such a novel approach to this and saying, suppose we have the exact same thing except the total area is 150 square feet. Well, it's just the same exact steps, only we have 150 instead of 100, so we're not going to work through that one. This problem is not in your book, but gives us just a little different look at things here. So Eduardo has two square pictures surrounded by 2-inch frame as shown below. The combined area of the pictures and frame is 126 square inches. What is the side length X of each square picture? And I kind of messed up trying to draw this. So the part on the right that's got the red X over it, imagine that's not there. So if we find our dimensions going across this rectangle, all the way across here, remember both of these have the same dimensions for these squares. So all the way across, the border's the same all the way around. That would be 2x plus 4. That would be like these 4 pieces here. And then similar idea going up and down here. This would be x plus 4. So we know the area of a rectangle's length. So 2x plus 4 times x plus 4, length times width, equals 126. So since this isn't something times something equals 0 like we had earlier in the chapter, we're going to have to go ahead and work through some things here. So we're going to first of all distribute or FOIL this, if you want to say. And then middle terms can be combined together. So the next thing is we're going to subtract 16 on both sides of the equation. Normally, our idea would be actually to subtract 126 on both sides, set it equal to 0, and try to factor it. I'm just doing this just because it's in the completing the square section, so I'm assuming this is not going to be factorable. Actually, I'm not quite ready for that yet. And then, since I have a number in front of the x squared term, we're going to need to divide to get rid of that. So everything needs to be divided by 2. The question as we were working through this was, why don't we just go ahead and divide by 2 earlier on, or what difference does it make? The difference is right now at this point, I only have to divide 3 terms. Instead of earlier, I would have had to divide by 4 terms. Also, if let's say the 16 and the 126 were both odd numbers. If you divide an odd number by 2, that's going to be decimals, and then you subtract and it would have worked itself out if they were both odd. Whereas if you would have subtracted it and they were both odd, then you'd get an even number. Divide by 2 comes out evenly. So potentially it's just nicer numbers and less dividing if you wait until this point. But if you're afraid you're going to forget to divide it and you want to do that earlier on, you can. So at this point now our B term is 6, and so half of that is 3, and we square that is 9, means we need to add 9 on both sides. And these numbers are actually looking pretty nice here. So this actually works out that we could have factored it and not had to complete the square. If we would have known, we could have done this a little easier, but this is okay. It's more practice for us. So now on the left side we can factor this. And remember, they should factor both the same. This should be a binomial squared when we're done. So that's x plus 3 times x plus 3, which is quantity x plus 3 quantity squared. Then we'll take the square root on both sides, plus or minus. Square root of 64 is 8. They're adding 3, we can subtract 3 on both sides. I'm going to squeeze that in front of the plus or minus 8. And then we're just going to look at both cases. It's either negative 3 minus 8, or it's negative 3 plus 8. So negative 3 minus 8 would be negative 11. Negative 3 plus 8 would be 5. And x is the side length of our square. The side length of our square can't be negative, so that doesn't work. So 5 inches would be the actual length. And like I said, if we went back to the point before we subtracted 16 on both sides, if we would have subtracted 126 on both sides to set this equal to 0, we could have factored out a 2. And then this should be able to factor since the answer came out evenly. So plus 11 and minus 5 should work. And then if you work that out, this would be negative 11 and this would be 5. So again, hindsight, if we actually didn't need to worry about completing the square on this problem. Look at the lesson check number 4, because this is one that has a number in front of the x squared term. On this one, we're actually ready to go ahead and divide everything by 2. And I'm just going to leave that as 135 over 2. I'm not even going to mess with the calculator at this point. So our b term here is 3 halves. If we take half of that, half of 3 halves is 3/4. And then if we square that, that would be 9/16. So we need to add 9/16 on both sides. This is part of why I kept that fraction over there. So then over on the right side, we can get a common denominator of 16. So we combine those together, would end up being 1089 over 16. And then we can factor this. If you wanted to do the factoring earlier, we could have done that. So half needs to go on each one. So half of 3/4, or sorry, half of 3/2 again would be 3/4. So it'd be z plus 3/4 times z plus 3/4, or z plus 3/4 quantity squared. Then we need to take the square root on both sides, plus or minus. And we can split that fraction up. So square root of 1089 doesn't come out evenly. Square root of 16 does, which once again is the same as our denominator on the other side of the equation. So then we subtract 3/4 on both sides of the equation. And then both of these have denominators of 4, so we can combine that as one fraction. And then we can look at both parts of this. So this would be the exact answers. And then if we wanted approximate answers. So actually, square root of 1089 doesn't look very nice, but it actually is 33. So we can actually work this down all the way. So it'd be -3 minus 33 over 4, or -3 plus 33 all over 4. This would be -36 over 4, or 30 over 4. So if we divide this out, these end up being -9. The other one ends up being 7.5 or 7.5. And again, since those numbers came out kind of nicely, potentially that means we might have been able to actually factor it instead of doing the completing the square. But we got to practice them a little bit sometimes, otherwise we're not going to know how to do those. So this gives you an idea of how to complete the square.